So previously I solved a problem using the angles and using rational numbers to solve a simple case. What would happen if we try and do it on a more difficult case? So in this particular case, let's consider that we've now got the mass coming down, 100 newtons, and then we've got one bit of string here going off in this direction at 45 degrees. Let's work out the complementary angle there, so that's going to be 45, makes it add up to 90, and then we'll have another bit of string which is taking a bit more of the mass there, so it is at an angle of 30 degrees. And what's its complementary angle going to be? So that's going to be 60 degrees to get from there to there. Okay, so that's my T1 and my T2. So I've gone straight in and I've drawn the free body diagram of the problem. So we're now not going to use irrational numbers, but we're going to use the angles and rational numbers. So we're going to sum up forces in the x direction. And what do we have? Well, this one here I've decided it's going to go left to right to be positive. This one here I'm going to swing it down to this axis here, so it'll be pointing in a negative sense to my arrow pointing in the positive sense. So we have minus T1 swing through 60 degrees, so cos 60. This one here would swing through 45 degrees, plus T2, it's now pointing in a positive direction, equals 0. So I've got to let something equal something, so I will let T1 equal T2 cos 45, and then I need to divide through by cos 60 to get T1 by itself, so cos 60. Right, so I've gone as far as I can with this. Now what I want to do is put off the scenario where I'm using my calculator. Right, so it's tempting to use my calculator at this point, but until it's my final solution I will not use my calculator. So let's move on to the forces going in the y direction. Okay, so the first one I can see I need to swing through 30 degrees. So I've got T1 cos 30. This one here I've got to swing through 45 plus T2 cos 45. Do you see one advantage of always using coses? Not only is it easier, what we're saying to ourselves is, oh, we have to swing through that angle, but when I combine this and this together, I've got a cos 60 and a cos 30. I know that they're different things. Anyway, let's carry on. So that's those two things swung through and going upwards. Then we've got minus 100 newtons going straight down, equals 0. Right, so next stage is we've got to decide what substitutes into what. So we're going to get rid of the T1 and substitute the T2 in this expression here on the left. So we'll have T1, I'll replace that with T2 cos 45 divided by cos 60. Okay, so that's me replacing that with that. That's my equation 2. I need to multiply that all by cos 30. Then I've got plus T2 cos 45 equals, bring the 100 over to the right hand side, 100. Right, so let's factorize this before we go on. So T2, open my bracket, and I'll have cos 45 divided by cos 60 multiplied by cos 30 plus cos 45 divided by, close my bracket, equals 100. So this is a right mess here, and that's the mess that I now want to stick into my calculator, really, before I carry on doing any more algebra. So T2 multiplied by cos 45, using my calculator, yeah, divided by cos 60, multiply it by cos 30 plus cos 45. So that's close the bracket. So that is all that expression stuck into my calculator. So let's hit equal. Oh, look, my calculator wants to tell me the answer in irrational numbers, but I don't want that. So I press the SD button and I get 1.931. If you're doing it this way, always work to 5 sig fig. 1.931, that's 4 of them, and a 9 is the last one. Okay, so 1.931, the 8 I'm going to round up to be a 9, equals 100. Therefore T2 equals 100 divided by that number. Whoops. So I've got 100 divided by my previous answer, it wants to tell me in irrational numbers still, is 51.964, had to round that up again, newtons. Therefore we go back to here to find what T1 is. T1 equals 51.764 multiplied by cos 45 divided by cos 60 equals, so we're taking our previous number. I'm going to, if you've always got the number available, I'm always going to go back to the original number and not what I've rounded it up to be the number. So times it by cos, that's if you got it available, don't sweat if you don't, 45, okay, and then divide it by cos, you see that we need to be there, so cos 60, close my bracket, equals, okay, now it's starting to not cope and work in irrational numbers, rational numbers. So we got an answer of 73.2, and we do our final answers in 3 sig fig. So that's the rule. We're going to work in 5 sig fig, and we're going to present final answers in 3 sig fig. So final answer will be T2 equals 51.8 newtons. Okay, so that's working with angles, working with rational numbers, and that's what I would do. So principles that I'm following there is I'm not going to use my calculator until I actually have to, forced into it, and then when I need to calculate a big mess like this, then I'll turn to using my calculator at that point. That's the principle you should try and follow.